Hello everyone, this is Tarun Gaud from Data Science Department. I'm here to explain the machine learning for expert systems and data analysis for the mathematical logic in artificial intelligence subject. Let's go into the topic. Machine learning for expert systems in data analysis. Introduction to machine learning in expert systems. Machine learning, that is ML, enhances expert systems by enabling them to learn from data. Expert systems traditionally relied on rule-based logic, but ML introduced adaptability. The integration of ML improves decision-making accuracy and system flexibility. What are expert systems? Expert systems are AI programs designed to emulate human expertise in specific domains. They use a knowledge base and inference engine to solve complex problems. These systems support decision-making process across various industries. It is a picture for the expert systems, uh, user interface, inference engine, knowledge base. It is the transmission from user interface to knowledge base, from the knowledge from an expert to non-expert user. Just go through that images for more clarity. Overview of machine learning techniques. ML techniques include supervised, unsupervised, semi-supervised, and reinforcement learning. Each technique serves different data analysis needs within expert systems. Selecting the appropriate ML method depends on the problem and available data. Here are the different types of machine learning types that are supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. In supervised learning, there are regression and classification. Coming to the unsupervised learning consists of clustering, dimensional reduction, and then semi-supervised learning, clustering and classification. And last, reinforcement learning consists of control and classification. These are the various machine learning techniques according to their usage. Role of data in machine learning for expert systems. High quality relevant data is critical for effective ML model training. Data pre-processing ensures data consistency and remove noise. Proper data management enhances the accuracy of expert system predictions. Artificial intelligence AI for clinical infectious diseases corresponds to a system that emulates the decision-making ability of a human expert in a specific task. This includes two various kinds: expert systems and machine learning. In expert system, there are knowledge-based inference engine, knowledge-intensive or knowledge-based system. It's an old AI. And machine learning is sometimes called machine learning clinical decision support systems, MLCDSS. It supports various algorithms, data-intensive systems. The approaches are vary based on the implementation. Just go through with the flowchart of the expert systems and machine learning. Supervised learning in expert systems. Supervised learning uses labeled data trained models for classification and regression tasks. It enables expert systems to predict outcomes based on historical data. Common algorithms include decision trees, support vector machines, and neural networks. This is the supervised machine learning algorithm flowchart. From the dataset, data retrieval, and from the data retrieval, data pre-processing, feature extraction, feature selection is the overall process of data preparation. And it is connected to the modeling, and from that model evaluation and tuning, and then deployment and monitoring. Reiterate till satisfactory model performance. For the satisfying the model performance, we can reiterate the data preparation process from model evaluation. This is the machine learning algorithm, specifically supervised machine learning. Unsupervised learning applications. Unsupervised learning finds hidden patterns or groupings in unlabeled data. It is useful for clustering, anomaly detection, and market segmentation. Techniques include k-means clustering, hierarchical clustering, and PCA, principal component analysis, that PCA means. Here are some applications of unsupervised learning like market basket analysis, medical diagnosis, marketing, insurance, earthquake studies. Semi-supervised and reinforcement learning. Semi-supervised learning leverages small amount of labeled data with large unlabeled datasets. Reinforcement learning trains the system through to rewards and penalties based on actions. Both approaches expand the capabilities of expert systems in dynamic environments. Here is the semi-supervised learning approach, which consists of large amount of unlabeled data and a small amount of labeled data. These both combined with the machine learning model and pseudocode labeled dataset will be provided. And from that, ML model trained on pseudocode labeled data and labeled data, for the predictions, it will either a square or a triangle based on the given data sets. Building expert systems with ML, that is machine learning. Combining rule-based logic with ML models, creating hybrid expert systems. These systems can adapt to rules based on new data insights. Implementation involved continuous learning and updating of knowledge bases. It is the architecture of an expert system from the non-expert user to the expert user, having the components of user interface, in inference engine, knowledge base, knowledge acquisition module, explanation module. Benefits of ML enhanced expert systems: improve accuracy and efficiency in the decision making process, greater adaptability to changing data patterns and environments, reduced reliance on manual rule creation and maintenance. Advantages and disadvantages of the applying ML in expert systems, like a simulate was scenario, prove unit training, shows ways to combat attacks based on the experience, improve existing systems, alert and prevent future accidents, create autonomous missions. These are the benefits of the machine learning expert systems. Challenges in integrating ML with expert systems: ensuring data quality and relevance for robust model training, managing the complexity of combining rule-based and data-driven approaches, addressing interpretability and transparency of ML models within expert systems. Case study: medical diagnosis expert systems. ML models assist in diagnosis diseases based on patient data. Expert systems enhances decision support with the real-time data analysis. Result shows increased diagnostic accuracy, faster decision times. Case study: financial data analysis. Expert systems use ML to detect fraudulent transactions and credit risks. Pattern recognition helps in predicting market trends. These systems improve risk management and compliance. Tools and technologies for ML in expert systems. Popular frameworks include TensorFlow, Scikit-learn, and PyTorch. Knowledge representation tools support rule-based and data-driven integration. Cloud platforms facilitate scalable data processing and model deployment. Future trends in ML for expert systems: increasing use of deep learning for complex pattern recognition, integration of NLP, that is natural language processing, for better user interaction, development of explainable AI to improve transparency and trust. There are many trends. Here are the top 5 machine learning trends to watch in the future. Just go through with the image for the top future trends. Ethical considerations: ensuring data privacy and security is a paramount. Addressing biases in training data to prevent unfair outcomes. Promoting transparency to foster user trust in expert systems. Ethical, legal. Uh, just go through with the ethical considerations diagram for more information. Best practices for implementation: start with a clear problem definitions and data collection strategies. Prioritize model interpretability alongside performance. Continuously monitor and update models to maintain effectiveness. Here are the best practices for implementation: strategic goal setting, planning, design, decision making, quality control and monitoring, diagnosis. Challenges in deployment: integrating ML models into existing expert system architectures can be complex. Yeah, it is very complex for integrating the ML models in the existing expert systems. Ensuring system scalability and real-time processing capabilities, managing user acceptance and training for new system functionalities. Case study: manufacturing quality control. ML models analyze sensors instant feedback to manufacturing lines. This approach reduces waste and improves product quality control in manufacturing. Conclusion and summary. Machine learning significantly enhances the capabilities of expert system in the data analysis. Combining rule-based on data-driven methods creates more adaptive solutions. Ongoing research and technological advancements promise further improvements. Yeah, that's it. Thank you. I hope you will understand something from this presentation about the ML, that is machine learning in expert systems from the artificial intelligence. Thank you. Thank you so much. Thank you for the opportunity.